A block of weight 100 Newton is suspended with the help of 3 strings as shown in the diagram. Find the tension in each of these strings. String 1 may be the weight hanging down. String 2 connected from O to A. String 3 from O to B. So the downward force is the weight. So if we mark the downward tension as T1, it's nothing. T1 is just given as 100 Newton, value given directly. So one of the question, 3 strings. One string, the tension T1 is 100 Newton. This you can mark as T2 because it's pulling the mass to the left. Then this string, the tension you can mark as T3, it's pulling the mass up. So the angle made at the top with the vertical is 60 degree. If you draw a dotted line here, if this is 60, this angle will be 60 degree. Now for finding the other tensions, this T2 is towards left, T1 is vertically downward, T3 is not horizontal or vertical, it's inclined. So we resolve T3 into horizontal and vertical components. Then you can equate the right component towards T2 equal and the upward component equal to T1. For equilibrium, the net force has to be 0. Net upward force has to be equal to net downward force. So the downward force tension is T1, that's weight 100 Newton. The left one is T2 and the top one is T3. We are resolving T3 into 2 components. So just duplicating the diagram here. This is the line O to B. We are resolving that into horizontal and vertical components. This is a horizontal component. The vertical component. The angle at B is 60 degree, so this angle at O with the vertical is 60 degree. So this component will be the opposite component and the vertical component is adjacent to the angle. The adjacent component to the angle will be always cos component. So this will be T3 cos 60 and the opposite component. These two are equal, opposite. This component will be T3 sin 60. Vertical T3 cos 60 and the horizontal, the opposite sides are equal. So this also T3 sin 60. Now if you compare with the other already existing components, T2 is towards left. So for this system to be in equilibrium, the net force towards left has to be equal to the net force towards right. So you can equate T2 equal to T3 sin 60. Same way, the downward force has to be equal to the net upward force. Downward force is 100 Newton, which is T1. That has to be equal to T3 cos 60. So we will start with the downward and upward component because this value already been known. So you can put T1 equal to T3 cos 60, which means 100 equal to T3 cos 60. Now cos 60 sin 30 1 by 2. The 2 will go to the left. So 200. So T3 equal to 200 Newton. Now if you know T3, you can find T2 as T2 equal to T3 into sin 60. So T2 is equal to T3 into sin 60. Now T3 is already 200. Sin 60 is root 3 by 2. Root 3 is 1.73 by 2. So the 2 and 100 will 200 will go, 100 will come, 100 into 1.73 will be 173. Okay. So these are the tension on each wire. T1 downward, that is 100 Newton. T2 which is towards left will be 200 Newton, and T3 is 200 Newton, and T3 is 200 Newton, not T2, and T2 towards left is 173 Newton.